Okay, going over some of the Unit 4 exam questions. The first question that we're going to look at deals with writing the equation of a quadratic function given a vertex and a point. Okay, so since it gives you the vertex, focus on this equation in vertex form. Okay. The 1, -1 is going to be your HK. So that means I can substitute here a -1 squared, and then since K is -1, I'll put a -1 there as well. Remember the H changes signs because it has a minus in front of it. Now this other point, the 2, is your XY. So any point on the graph should be able to be plugged in for x and y into the equation. So if I plug them in here for this x and y, then I've got 2 equals a times 1 minus 1 squared minus 1. Okay, so work out the parentheses first. 1 minus 1 is going to be 0. So, so there's a problem. Here we go. This is why. That x is actually 2, not 1, from right here. Okay, that looks better. So 2 equals a times 1, because 2 minus 1 is 1, 1 squared is 1, and then minus 1. Now, a times 1 is just a. So write 2 equals a minus 1, and then solve for a. You end up with a equals 3. So that means your equation is going to be y equals 3, because I'm plugging in that number for a, and then x minus 1 squared minus 1. So in the end, I plug in for a, h, and k, because normally we do have an x and y in the equation. Okay, and so you can leave your equation in vertex form. They multiplied that out and got standard form, but it doesn't ask for that, so I'm fine with vertex form. So that's number 1. Okay, for 2, it says to solve, and you have x to the third minus x squared minus 6x is less than 0. So first of all, I need to take this part and factor it. So there's a GCF there of x. And I'm just going to solve as if it's an equation to start with. Okay, I do have factors of -6 that add to -1. So that would be a -3 and a +2. So that means my critical numbers, which are just the solutions to that equation, are 0, 3, and -2 from those 3 factors. Okay, so now we have to figure out, since this is actually an inequality and not an equation, the equation helped us come up with those critical values, but now I have to put those critical values on a number line and see what sections of the graph are true and which ones are false, so that way I know which way to make my interval. So I have -2, 0, and 3. So I need a number to the left of -2, something over here in this section that's less than. So like say -3. Okay, so I need to test -3. That means I plug a -3 in for x back here. So that gives me -3 to the third minus a -3 squared minus 6 times -3. I need to see if that's less than 0. So I'm just going to plug that into my calculator. And when I plug that in, I end up with negative 18. So is negative 18 less than 0? That is true. So that means this part is shaded. Now I'm going to pick something between negative 2 and 0. And I'm writing kind of big here, so I'm just going to squeeze this in at the top. I'll use a different color so you can tell that it's a different section. So if I check negative 1, then that means I just go back in and put negative 1 in for x. And you should be able to just copy that line on your calculator so you don't have to type it all in again, and just change your negative 3's to negative 1. I need to see if that's less than 0. That gives me 4. 4 is not less than 0, so that's false. That means I do not shade in that section between negative 2 and 0. Okay, now I need to check something between 0 and 3. So let's say I check a positive 1. So that means 1 cubed minus 1 squared minus 6 times 1, and see if that's less than 0. So this time I'm going to copy my previous line where I plugged in negative 1, and I'm just going to go back and arrow over the negatives and delete them. So I don't have to type in that whole equation again. Typing this in on my calculator on my computer, and I'm just so slow at that. Okay, so that gives me negative 6. That is true. That means this area is also shaded. Okay, now I need to pick something to the right of 3, like maybe a 4. So when I check 4, I'm going to say 4 cubed minus 4 squared minus 6 times 4, and I need to see if that's less than 0. So once again, I'm going to copy my previous line, but I'm going to go back and change those 1s that I plugged in. I'm going to type over those and make them 4s. So it just saves a little bit of time there. That gives me 24. 24 less than 0, that's false. Okay, so now I go back and I look at my number line, and I have these two sections shaded. So that means my answer is negative infinity to negative 2, because that's the section that's shaded there, and then 0 to 3. Now I used parentheses there because my original inequality just said less than and did not say or equal to. Okay, next is question 5. And we just need to look at the domain. Nope, the range. Of y equals 5 to the negative x minus 4. Okay, using your transformation rules, this minus 4 tells me the graph goes down 4. Okay. Normally, an exponential graph will have an asymptote at 0 at the x-axis. This means that it's actually going down 4, so now I have an asymptote at y equals negative 4. Okay, so that makes my graph go from negative 4 to infinity. Okay, and you can see that as well by looking at the graph. Okay, next is number 11. You need to graph y equals 12x minus 3. And then you need to graph the inverse, which is x plus 3 over 12. and then you need to graph y equals x. Okay. Now, this second one is going to be kind of messy. These are both lines, so you can graph using y equals mx plus b, or you can get points off of your table to graph. So this one wouldn't be terrible using y equals mx plus b because it does give you plenty of room on your graph for a slope of 12. So you would go down 3 and then go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and over 1 to get that line, to make your second point. Okay. Now, the hard part is going to be this second one, okay, because that is a line as well, but technically this would be y equals 1/12 x plus a fourth. So starting your graph at a fourth is going to be somewhat difficult because it's a fraction. So what I would do instead is pick the points that you have from up here. So we had a point at 0, negative 3, sorry. And then my other point was at 1, and I think that's 9, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 9. Okay. Okay, the inverse points for those would just be flipping them. So negative 3, 0, and 9, 1. So I would think it would be easier to graph those 2 points to get your inverse graph. So 1, my pen's out, there we go, 2, 3. So negative 3, 0, and then 9, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Okay. And then your y equals x line is just a diagonal line through there. So just make sure you graph like 0, 0, and then 1, 1, or 2, 2, or negative 3, something like that. Okay. This is the trick on that one, because that's just going to be way too messy to graph. You could try to graph about where you think is 1/4 and then try to edit the coordinates, but that just gets a little complicated. Okay, next question. You need to factor. So if you're going to factor, you want to make the equation equal 0. So when you move things over, make sure you put them in the correct order so that your polynomial on the left is in descending order. Okay. So my x squared and 2x become minus because they switch sides. Okay, when we factor terms with 4, or factor polynomials with 4 terms, we group. So on the left, my GCF is x squared, leaving me with 2x minus 1. And then on the right, 2x and 1 do not have a common factor, so I'm just going to factor out a 1, and actually it's going to be a negative 1 because of that sign there. Now remember your goal, these have to be the same. If they're not, check and see if you forgot to take out a negative, or if you didn't take out the GCF, something like that. Okay, it may not be factorable if you can't find a mistake. So, but this one should be, because it says find the solutions by factoring. Okay. So I write down what both sides have in common, and then my remaining factors are x squared minus 1. So now when I set those equal to 0, I end up with 1/2. And then for my other factor, when I take the square root of 1, I have plus or minus 1. So you have 3 answers. You have 1/2, 1, and negative 1. Okay, this one gives us zeros of 5, and it has a multiplicity of 2, and then 2i. And you have to write the equation. So that's basically taking number 12 and working backwards, okay? So like that 1/2 came from the factor 2x minus 1. The 1 and negative 1 came from the factors x squared minus 1. Okay. So when I look at my zeros, let's start with the 5. That's going to come from x minus 5. But it says it has a multiplicity of 2. That just means that factor is squared. Okay. Now, the 2i would come from the factor x minus 2i. And then even though it doesn't list it, you also have to include the negative 2i because i's always come in conjugate pairs. So that gives me another factor of x plus 2i. Okay. So when you multiply these out next, you're going to want to multiply the conjugate parts together, so the I parts. So here I have x squared minus 4i squared. That gives me x squared plus 4. So the reason I multiplied those together is because outside and inside cancel. So if you know that, then you can just multiply first and last. It's a little bit of a shortcut. Now for x minus 5 squared, this means x minus 5 times x minus 5. So when I multiply that out, I end up with x squared minus 10x plus 25. Now I have to multiply these two together. Now, I prefer to distribute the one with a smaller number of terms, so I'm going to distribute the x squared plus 4. Just looks a little funny because I have it in the back, so that's x to the 4th minus 10x to the 3rd plus 25x squared, and then go through and distribute 4. 4x squared, and I'm lining up my like terms here, minus 40x, and then plus 100. So now that makes my function x to the 4th minus 10x to the 3rd plus 29x squared minus 40x plus 100. Whoops, not 400, 100. Okay, on 14, we have 7x to the 3rd plus 3x squared minus 29x plus 11 equals 0. Now, this doesn't factor, so when it doesn't factor and you have to solve, this is when we use our P over Q test to see what the possible rational zeros are. So factors of 11 over factors of 7. So my potential rational zeros would be plus or minus 1, 11, 1/7, and 11/7. Okay. So pretty good chance this one could have a fraction answer. So to figure out which of these we should try in our synthetic division, I'm going to go ahead and set up the inside, but then to figure out what number goes on the outside, we're going to use our calculator to see where it looks like it crosses the x-axis, because x-intercepts are the same as solutions or zeros of a function. So I'm going to go to my y equals, clear out anything I have there. Whoops. And on y1, I'm going to type in the original problem, 7x to the 3rd plus 3x squared minus 29x plus 11. Okay, so when I look at my graph, my nice possible answers were like 7 and 11. And -7 and -11. So definitely not looking like one of those. It was hard for me to see. My calculator app doesn't really show the x-axis very well. So I was looking at the table. You want to see where your solutions are zeros. And I did not have a 0 at any of those nice numbers. Okay. So if I'm looking at the others, it looks like it crosses a little past maybe 1. It's definitely not a 1/7 because it's too far away. And there's my, it could be. So 1/7, or I really think it looks more like 11/7 here, because 11/7 is 1 4/7, and that looks like it's almost in the middle of 1 and 2. So I'm going to try 11/7. So bring down my 7. When I multiply, it gives me a nice number. And sure enough, that works. Okay. Now, more than likely, my other 2 answers are not nice answers because they did not look like it crossed in a nice place. So that means it's probably not even one of these other fractions in our list up here. It's probably an irrational number. Definitely not an imaginary number, though, because we did see 2 other x-intercepts. So if it's an irrational number, that just means it probably has a radical in it. So we would need to do the quadratic formula with my answer here. A is 7, B is 14, and C is -7. So I have x equals -14 plus or minus the square root of 14 squared minus 4 times 7 times -7 all over 2 times 7. Okay, so I want to put this part in my calculator so I can figure out what that's equal to. So we have 14 squared minus 4 times 7 times -7. That gives me 392. Okay, 392, does it have a square root? That's a big number, so I don't have that one memorized. And so I put it in my calculator. Sure enough, it does not have a square root. So I'm going to look for factors of 392 that do have a square root. Now, this shortcut here, go to y equals, I'm going to clear that out. If I type in 392 divided by x, I can look at my table and get some possible factors. So I have 1 in 392, 2 in 196. I'm pretty sure 196 has a square root. Let's check it out. The square root of 196 is 14. So yeah, that's what I need to use there from my table, the 2 and 196. So if this is 2 times 196, we said the square root of 196 was 14, so 14 radical 2. Okay, so now I have -14 over 14 plus or minus 14 radical 2 over 14. So -14 over 14 is -1, and then those cancel. There's my other 2 zeros. Okay, next problem is going to be very similar. This one's number 15. We have f of x equals x to the third minus 9x squared plus 31x minus 39. So that's not factorable either. So when I go to find the zeros, and it tells me find the complex zeros, so you're probably going to end up with some I answers. So when I go to my calculator, go to y equals, and type in the problem, and hit graph. Why is nothing showing up? look at the table. It's saying error. Okay, what did I do? Oh, I think my exponent on the 2 when I typed in the wrong thing got messed up. There we go. Yeah, I think I made it an exponent twice. There we go. Okay, so you can definitely see on this one it crosses at 3. And if you want to verify that, look at your table. Sure enough, at 3, I have a 0 in the sign. So this time, when I do synthetic division, I used a 3. And I got by with not doing the P over Q test this time. And that's just because we ended up with a nice answer. If you did not do the P over Q test on problem 14, I mean, how would you figure out that's 11/7? Okay. So since we had a nice answer, a whole number answer, we could see that on our calculator pretty easily as far as the x-intercept goes. So if you have an integer answer, you can probably get by with not doing that. All right, bring down the 1, work through this, and make sure you end up with a 0 for your remainder. And so now when I do the quadratic formula, once again, I need to put that in my calculator. So minus 4 times 1 times 13. That gives me negative 16. Okay. And negative 16 has a square root of 4i. And so that's going to reduce down to 3 plus or minus 2i. So your zeros are going to be 3 plus 2i, 3 minus 2i, and then when you write those as factors, that's the second part of the question, it's going to be x minus 3, x minus 3 plus 2i, and x minus 3 minus 2i. Now, it's not going to like the double parentheses there, so take your negative sign and distribute it so you can drop those. That's your answer. Okay, on 16, when you're solving that log equation, you're going to do the curly fry to rewrite it. So 4 to the 4th equals x squared plus 4. Okay, 4 to the 4th is 256. And so when I subtract 4, I end up with 252 equals x squared. So now I have to square root that. And 252 does not have a square root, but when I go to my y equals and type in 252 divided by x, whoops, not in the right spot. There we go. Go to your table. And I'm looking through here. I've got several factors, but I want the factor, the largest factor that has a square root. So 4 has a square root, but 63 is still pretty big. So keep looking. There we go. 7 and 36. Okay. Now 36 is still pretty big, but since 7's prime, that's how I know that's the magic number. So I'm going to say 7 and 36. And the square root of 36 is 6. 7 doesn't have a square root. Now, this is technically plus or minus. And even though we can't take the log of a negative, this will still work because we're squaring that negative. So we don't end up taking the log of a negative. Okay, 23. I'm thinking maybe you've got the complicated answer right, but not the decimal. I'm thinking maybe we just typed it in on the calculator wrong. So let's make sure we've got that down. Use your fraction button and type in the numerator, -9 plus the square root of 197 over 2. And that should be 2.518. Okay. If you type it in with the divided by, that's fine, but you need to put parentheses around the numerator. Otherwise, it thinks it's only dividing the radical 197 by 2. Okay, last question. Is 24. This one is not factorable because there are no factors of 20 that add to -4. It kind of gives you a hint too because it says solve in the complex number system. So that means you're probably going to need to do the quadratic formula because there's a good chance you could have some I answers. So -b plus or minus b squared minus 4 times a times c all over 2 times a. So just like we saw on some of the previous problems, we want to put that in our calculator. So -4 squared minus 4 times 1 times 20 is -64. Square root of -64 is 8i. So 4 over 2 plus or minus 8i over 2 gives me 2 plus or minus 4i. Okay, that is it.